Hello everyone, here with them presenting a video lecture on corrosion control methods and metal finishing. So where I am going to discuss about the various methods to prevent corrosion as well as about metal finishing and its advanced applications. Corrosion control. We know that corrosion is a natural process and it is nothing but destruction of the material by various environmental facts. So how this corrosion could be prevented? So we can prevent this corrosion process using suitable protection methods. So we can prevent it by selecting various technique like following the protective coating of the metal surface, or by considering some environmental measures, or by using cathodic protection, or using corrosion inhibitors, or considering some design modification of the article, etc. So in this video lecture we will be highlighting about a few important technique that is used to control corrosion. So we will be highlighting about cathodic protection as well as about some metal coating technique. So first one is cathodic protection. So what do you mean by cathodic protection? So as the name indicates here, this method involves the protection of the metal from corrosion by converting it into cathodic. So we are all aware about the mechanism of corrosion. That is, during the corrosion process, oxidation takes place near the anode surface and reduction takes place near the cathode surface. So cathode do not undergo corrosion during the corrosion process, and only the anode part gets destructed. So here we convert the metal surface to behave like cathodic. So this can be defined as a method to protect the metal or alloy from corrosion by converting it completely into cathodic, because cathode do not undergo corrosion, and this method can be achieved by connecting the metal to an external anode or a DC current. So here we have mainly two methods under cathodic protection, that is sacrificial anode method and impressed current method. So first one is sacrificial anode method. So sacrificial anode method, here the metallic structure or the metal that we want to protect is protected by connecting to more active metal. So we need to take the metal which can act more active compared to the material which we want to protect it. So here the metallic structure to be protected is connected to more active metal with an insulated copper wire. So here the metal structure acts as cathode. So once we connect it to more active metal, the original metal structure acts as cathode and more active metal acts as anode. So what happens here? The more active metal gets corroded or destructed. So the metal surface or the metal structure remains unaffected since it starts acting as cathode. So the more active metal itself gets corroded while the metal structure is protected. The more active metal employed, we call it as sacrificial anode, and the corroded sacrificial anode block is usually replaced by fresh one once it is damaged completely. So usually the common metals that we employ as sacrificial anode metals are magnesium. So magnesium is always considered as more active metal. It is placed in top of the galvanic series also. So other than magnesium, even zinc, aluminium and their alloys are also used as sacrificial anodes. So what are the application of this sacrificial anode method? So mainly this method is used for the protection of pipelines, underground cables, marine structures, ship hulls or water tanks, etc. So next one is, so here you can see the diagram which represents the sacrificial anode method, where we are trying to protect the steel pipe by connecting it to a magnesium block. So here it is clearly indicating that the metal structure that we want to protect is a steel pipe, that through the electrical conductor we have connected to more active metal, that is the magnesium block. So here once you connect it to magnesium or the more active metal, the more active metal start acting as anode, and it will protect the steel pipe from corroding, because it makes steel pipe to behave like cathode. Because when you compare magnesium and steel, here magnesium acts as anode and steel pipe acts as cathode. So here one more diagram where you can clearly observe the oxidation reduction process. So near the more active metal surface where it acts as anode, oxidation takes place. So Mg gets converted into Mg2 plus with the liberation of electron, and the liberated electron will migrate towards the cathodic side, that is near the steel pipe surface, and finally the steel pipe is completely protected from the corrosion process. So once this magnesium metal or the magnesium block which acts as anode is completely damaged by this oxidation process, then it is replaced by fresh one. So again it can be replaced by fresh magnesium block here. So next method is impressed current method. So in this method, the metal to be protected is made as cathode by connecting it to negative terminal of DC battery or rectifier. So usually we use the inert anode here, and the inert anode we connect it to positive terminal, whereas the metal which we want to protect we connect it to the negative terminal. So usually the inert anode materials that is connected to the positive terminals are usually graphite is taken, or high silicon iron is taken, or stainless steel or platinum metals are taken as inert anode in this impressed current method. So here what happens is the electrons supplied from the negative terminal of the DC battery. So it will convert the corroding metal from anode to cathode. So the metal that we want to protect, it starts acting as cathode, because the electrons are supplied from negative terminal of the DC battery, because we have connected this metal to the negative terminal of DC battery. So this is how the metal surface is prevented from the corrosion process. And where we can find the application of this cathodic protection method, and we can apply this method in open box coolers or water tanks or buried water pipes, condensers, transmission line towers, etc. So next method is about metal coating. Before that, you can see this diagram where you will get the clear picture where the tank which we want to protect, the metal body which we want to protect, it is connected to negative terminal of the rectifier or the DC battery. So when you connect it to the negative terminal, what happens? The electrons supplied from the negative terminal of the battery convert this metal body, the tank part, to behave like cathode, and it prevents corrosion. So here you can see the positive terminal is connected to inert anodes such as graphite, steel or platinum, etc. So here one more schematic diagram which gives a clear idea about impressed current method. Positive terminal connected to anode, negative terminal connected to steel pipe. So where you can see the movement of electrons also. So next one is about metal coating. So the first method, where it involves cathodic protection by two techniques, that is sacrificial anode method and impressed current method. And here we are going to explain about the metal coating technique. So as the name indicates, metal coating, here we can protect the metal or the material by the corrosion process by coating with suitable metals, so that it acts as a protective layer and protect it from the corrosion process. So here mainly we have two techniques, galvanization and tinning. So this galvanization technique is also called as anodic metal coating, whereas tinning process is also called as cathodic metal coating. So here this technique mainly involves deposition of protective metal over the surface of the base metal. So base metal is nothing but the metal which we want to protect. So how we define metal coating? It is nothing but the method of deposition of protective metal over the surface of the base metal. And we have two technique, that is galvanization and tinning process. So first one is galvanization. What do you mean by galvanization? So this galvanization is nothing but it is anodic metal coating process, and here the base metal surface is coated with zinc metal here. So usually the metal surface which we want to protect is coated with the layer of zinc metal, and to coat with this zinc metal we follow hot dipping method. So usually galvanization is carried out by hot dipping method. So it involves various steps, like first cleaning the surface of the metal or the base metal completely, and then coating with the coating the base metal with the another metal which you want to coat it. So here it is galvanization, so we are going to coat with zinc metal. So what are the steps involved in this galvanization process? So how we can define galvanization? It is a process of coating a base metal surface with zinc metal by following hot dipping method. So the steps involved in galvanization process are, first one is the cleaning of the metal surface. That is, the metal surface is washed thoroughly with organic solvents. So main intention of this step is to remove any oil or grease deposit from the surface of the metal. And once the oil and grease deposit is removed completely, then we need to remove any rust deposited on the surface, and this rust and other deposits can be removed by washing with dilute sulfuric acid. So first step is washing with the organic solvent, second step involves washing with dilute sulfuric acid, and this second step is also called as pickling process, that is washing with sulfuric acid to remove the rust content. And finally this water is the article or the surface of the metal is washed with water and it is dried completely, that is air dried. And after this cleaning process, finally the article is dipped in a bath of molten zinc, which is maintained at 425 to 430 degrees Celsius and converted and it is covered with the flux of ammonium chloride. So it is covered with the flux of ammonium chloride mainly to prevent the oxidation of molten zinc. And next step is, once you dip in the molten zinc tank, the excess zinc on the surface has to be removed, and this can be removed by passing through a pair of rollers. So the excess zinc on the surface has to be removed, and this process can be carried out by passing through the pair of hot rollers, so that it will wipe out the excess zinc coating, and it produces thin uniform coating on the surface of the article or the metal. So it involves mainly cleaning of the metal surface or the article, after that dipping the metal or the article which we want to coat in a bath of molten zinc maintained at high temperature, and also covered with the flux of ammonium chloride mainly to prevent the oxidation of molten zinc, and finally removal of excess zinc and making sure you will get a thin surface of metal covering. zinc coating on the metal surface. So this can be represented by this diagram also, where we can see the first step where it involves the washing of the metal surface with organic solvent, followed by washing with dilute sulfuric acid, and this second step is also called as pickling method, and the main aim of the second step is to remove the rust content on the surface of the metal. And after this, the metal body is washed completely with water and it is dried. So next one, it involves the dipping of the article in a container which contains molten zinc, which is covered with ammonium chloride. So here why we use ammonium chloride? Mainly to prevent the oxidation of zinc. So after this, the excess molten zinc that is deposited on the metal article has to be removed to get the uniform coating, thin uniform coating of the zinc on the article or the metal. So this can be done by passing through hot rollers. So article has to pass, a pair of hot rollers has to be passed on the article surface so that excess zinc can be removed. So this is about the galvanization process, and you can see the image which represent how this hot dipping method is carried out by dipping the article or the metal. Next is about the application of galvanization technique. So where this galvanizing process is used widely. So mainly it is used for the protection of iron from atmospheric corrosion, in case of your roofing sheets, wires, pipes, bolts, screws, buckets, tubes, etc. And we have some disadvantage also with this galvanization technique, where as we are going to coat the material with the zinc, so these galvanized articles are not used for preparing or storing food, because zinc dissolves in dilute acid and it produces toxic effects, and it will have more harmful effect on human body. So that is one of the disadvantage of galvanization process. So next one is about anodizing. So what is this anodizing? So here anodization process is nothing but here we will oxidize the metal surface to produce some adherent durable oxide scale by passing a electric current through an electrolyte, so that when it produces this durable oxide, it acts as a protecting layer to the metal body. So this is how we can prevent corrosion. So here mainly it involves the electrolytic oxidation of metal surface to produce a tightly adherent and durable oxide scale by passing electric current through an electrolyte to impart more protection from corrosion. So we have already discussed about the factors affecting corrosion under the nature of product, how it will influence the rate of corrosion. So if the nature of the corrosion product, if it is durable or if it is tightly adherent to the surface, or if it is uniform or non-porous, so we all know that then it will usually that type of product will prevent the metal surface from further corrosion process. So here in this technique also the same principle applies, because the oxide scale formed because of the corrosion process acts as a protection layer for the base metal here. So usually aluminium can be protected easily by using this anodization technique. Even zinc, magnesium and their alloys also can be protected by using anodizing process. But most of the cases non-ferrous metals are used, are protected by anodizing process. So how we carry this anodizing of aluminium? So we all know that during the corrosion process, aluminium will form its oxide, that is aluminium oxide. So how we carry out this anodizing of aluminium? So it can be carried out by electrolysis in suitable acid electrolyte. So usually we use acid electrolyte such as chromic acid or sulfuric acid or phosphoric acid, etc., by maintaining temperature around 35 to 40 degrees Celsius. And this aluminium is made as anode, and a plate of the lead or stainless steel is made as cathode. So the passed oxygen liberated at anode combines with and forms aluminium oxide, so which takes the form of thick film on the surface of aluminium. So the outer part of the oxide film formed is slightly porous, and in such cases we can make it highly non-porous, and it is sealed completely by simple technique, that is by dipping in boiling water. So this treatment converts porous alumina, nothing but aluminium oxide, at the surface of coating into its monohydrate, that is Al2O3H2O, so which occupies the volume. Thereby pores are sealed completely, and aluminium is prevented by further corrosion process. And this technique, as I mentioned, this can be used for other metals also, such as zinc, magnesium and their alloys. This anodizing technique is mainly used for providing highly durable roofs, ceilings, floor or staircases, etc. Where you can see the process of anodizing of aluminium, where the aluminium acts as anode, and it is dipped with the bath containing electrolyte bath containing acidic solution like sulfuric acid and or chromic acid or phosphoric acid. And uh, usually stainless steel is taken as cathode here, or a plate of lead is taken as cathode in most of the cases. So what happens here, progressive oxidation of aluminium to alumina takes place, Al2O3, as you can see from the diagram. Al is oxidized to Al2O3, and this alumina forms a coating on the surface of aluminium metal, where you can see the white dots deposited on the aluminium metal surface. So if the alumina formed is non-porous, then we can make it completely porous or sealed to the surface of the aluminium, so that the metal inside metal part is completely protected by simple dipping method in boiling water. So this is about anodizing process of. So this is about the most common technique used for the prevention of corrosion. That is, first one that we discussed is about cathodic protection, where it involves mainly two methods: impressed current method and sacrificial anode method. And also we have highlighted about some metal coating technique, where we have discussed about galvanization process, which is nothing but the coating of zinc on the metal surface, and also about anodization process, where the product of corrosion, where it can act as a protective layer for the metal body or the article that we want to protect. So now one of the advanced technology that we are all aware to prevent this corrosion is about metal finishing. So we have heard about metal finishing, which is a very common term that we observe. And here this technique is not only for the purpose of prevention of corrosion, it is used also mainly to modify the surface property of the metal, as well as to make the surface of the metal body or the article more attractive. So what metal finishing, actually it modifies the surface of the metal and it enhances the surface property. So if you observe metals, so these metal has played key role in most of the technological innovation. So we have various examples also for this. So but each type of metal has its own disadvantages, which has to be improved, because these metals are naturally occurring elements. So and these are extracted from earth crust by various process. It has converted into various types of articles. So this property of this metal can be improved by using this metal finishing technique. So how we define this metal finishing? So we can see the number of application that we observe in case of technology, maybe the circuit board that we observe, or the day-to-day life that we use, the basic need of metals. Finishing, we can define it as a process which is carried out in order to change the surface properties of the metal. And how we try to change the surface property of the metal? That is by depositing a layer of another metal. It may be metal or polymer, or by forming the oxide film on the surface of the metal. And we have mainly electroplating and electroless plating and metal finishing technique. So here it is a process carried out in order to modify the surface property of the metal. So the main objective of this metal finishing mainly to improve the appearance of the article or the metal, or to enhance the corrosion resistance, or to modify the surface property. So what are the importance of metal finishing? That is the technological importance of metal finishing, mainly to enhance the surface property as I mentioned earlier. But what type of surface property? So mainly it is used to offer corrosion resistance and also to give decorative surface so that the surface looks more attractive, and to impart abrasion resistance or wear resistance or thermal resistance, etc., and also to provide electrical or thermal conduction, and it can be used to offer the surface a thermal or optical reflectivity also, and to provide thermal insulating property also. Also it is used in the manufacture of electrical and electronic components, so mainly the circuit boards. So many industries use this metal finishing technique in their manufacturing process, including your automotive industries, electronics, aerospace, or telecommunications, or hardware industry, etc. So there are various factors that governs this metal finishing concept. So as I said, mainly we have two processes under metal finishing technique, that is electroplating and electroless plating. So here we have mainly three factors that governs this electroplating method. So what is this? What are these three concepts that we are going to discuss? That is, first one is polarization, then decomposition potential, and over voltage. So polarization. So what is polarization? So it is a process in which there is a variation in the electrode potential. So that a variation has generated, arised because of the uneven or the slow supply of ions from bulk of the solution to the electrode. So this potential is developed due to slow supply of ions from bulk of the solution to the electrode. So if you consider the electrolytic cell, when current is being passed and the process is carried out, what happens? The positive ions are produced at anode and it is consumed at cathode. But if the diffusion of ions in the electrolyte is slow, then what happens? So if the diffusion of ions are slow, then there will be accumulation of positive ion near anode itself. Similarly, there will be depletion of ions near cathode, because the whatever the positive ion is generated near anode, they are not able to move near the cathode area. So under this condition, what happens? Anode and cathode are said to be polarized, and this type of polarization also we call it as concentration polarization. So this polarization is arised mainly because of the slow diffusion of ions in the electrolyte. So when there is slow diffusion of ions, then there will be accumulation of charges, positive charge near anode or negative depletion of ions near cathode. So this is what polarization is, and how this can be minimized. So this polarization is arised mainly because of the slow diffusion rate, right? So what we can do is we can make the bath to be uniform, more uniform throughout the solution, and this can be done by use of agitation. So this can be minimized by the use of agitation in the plating bath, so that the constant stirring process is also there. Agitation makes the uniform concentration throughout the solution. So what are the factors that affects this polarization? So this mainly the size, shape and composition of the electrode, as well as the electrolyte concentration and its conductivity, and also the temperature, because mainly it depends on the rate of diffusion also, and the products formed at the electrode near anode and cathode, as well as the agitation process or rate of stirring. See, these are all the various factors that affects polarization. So mainly this can be minimized by maintaining constant rate of stirring or the agitation process. So this plays an important role in electroplating, because it helps us to determine the concentration and conductivity of electrolyte or electrode size, shape and temperature. So this can be used effectively during the electroplating process. So this polarization factor can be explained using your simple example by considering Daniell cell. As we all know, Daniell cell it consists of zinc and copper, where near the zinc electrode oxidation takes place, and near copper reduction process takes place. It acts as cathode, whereas zinc acts as anode. So in Daniell cell, as the current is withdrawn, the concentration of zinc ions around zinc anode increases, and the concentration of copper ions near copper cathode decreases. So there is depletion of ions near cathode, and increase of positive ion near anode. So this will reduce the tendency of further corrosion of zinc and deposition of copper. So the EMF generated will fall down, and we say the cell is said to be run out, or it is called as the cell is polarized. And about the next fact is decomposition potential. So what is this decomposition potential? So this is nothing but the minimum voltage which must be applied between the electrode immersed in the given electrolytic solution, so that there is continuous electrolytic decomposition. So this can be determined using electrolytic cell. So what is the minimum voltage required for the continuous electrolytic decomposition is nothing but the decomposition potential. So the minimum potential required for electroplating of a metal under a given set of bath condition is known as decomposition potential. So you can take the example of electrolysis of water here. So this is a graphical representation where we can see the decomposition potential. There is sudden increase near the ED point. You can see there is a sudden increase. So that point we call it as the decomposition potential during the electrolysis process. So in the, if you consider the example of electrolysis of water, a pair of platinum electrode immersed in a solution of acid electrolyte. So experimentally, if you calculate, it is observed that the potential is about 1.7 volt. So we need to apply 1.7 volt before the evolution of hydrogen and oxygen, because the cell is electrolysis of water process is taking place. So for the evolution of hydrogen and oxygen, experimentally we need to supply 1.7 volt. So the voltage at which the current increases suddenly, we call it as decomposition potential. So that is nothing but the potential that must be applied to a cell for the continuous electrolytic decomposition. So that is decomposition potential. So we can explain this concept by taking the example of electrolysis of water as I explained. So next, over voltage, or also it is called as over potential. So what is this over potential or over voltage? It is nothing but the excess voltage that has to be applied above the theoretical decomposition potential. So excess voltage that has to be applied above the theoretical potential to start the electrolysis process. So if you apply the voltage as per the experimental value, theoretical value, sometimes the electrolysis process may not initiate. So we need to supply some excess voltage also. So whatever the excess voltage that we supply for the electrolysis process initiation, we call it as over potential. So we have various factors that affect the over voltage, mainly the nature and physical state of the metals plays an important role here, as well as nature of the substance deposited, or the current density of the bath, temperature or rate of agitation, rate of stirring of the electrolyte also matter here. So here we can take the example of electrolysis of water, where the reversible potential of oxygen on platinum electrode is 1.3 volt. That is the theoretical decomposition potential is 1.3 volt, at which the actual evolution of oxygen on platinum occurs. But practically, experimentally, if you observe, for the evolution of oxygen, we need to apply 1.7 volt. So at 1.7 volt there will be evolution of oxygen actually. So the oxygen over voltage is the excess voltage that we have supplied. So theoretically the value was 1.3 volt, but practically it is observed that we need to supply 1.7 volt. So the difference between the two, 1.7 minus 1. So that gives the value 0.4 volt. That is nothing but the oxygen over voltage. Therefore the decomposition potential for such system can be calculated easily. So if you are clear about the concept of over potential, over voltage or decomposition potential. So next is about electroplating. So as I said, metal finishing, you have mainly two methods, that is electroplating and electroless plating. So what is electroplating? Also we call it as electro deposition. So it is the deposition of metal by electrolysis process. So where we are going to deposit on the surface of the substrate. It may be, the substrate may be metal, polymer, ceramic, or a composite material also. So electroplating is the process of deposition of metal by electrolysis process over the surface of the substrate. So mainly the mechanism involved in this electroplating, here the metal to be deposited, it is made to act as anode here, or the substrate or the article to be coated is made as cathode. And the main aim or objective of metal finishing is mainly, if in case of it is to prevent corrosion, then obviously the article has to be made as cathode, it has to act as cathode, then only the substrate or the article can be protected. So here it is achieved by passing an electric current through a solution containing dissolved metal ions and the metal object to be plated. So the metal object serves as cathode, as I mentioned, and the metal object serves as cathode in the electrochemical cell, and ferrous and non-ferrous metal objects are plated with variety of metals, usually by using aluminium, tin, bronze, cadmium, copper, chromium, nickel, zinc, etc. So we will be discussing about the mechanism of electroplating in detail before we proceed with the various electroplating examples, how the process is carried out. So what is the mechanism of electroplating? So here, as I mentioned, the metal to be deposited is made as anode and the article to be coated is made as cathode. So here anode and cathode are connected to a battery. So the positive pole of the battery is connected to metal to be deposited, so which is made as anode, and the negative pole of the battery is connected to the article to be coated. So the metallic solution of the metal to be deposited is electrolyzed to have a uniform coating of the metal on the cathode. So when the electrolysis is carried out, what happens? The anode dissolves into electrolytic bath, oxidation process. Metal ions from the bath gets deposited as pure metal over cathode. So simple mechanism, as we have seen in the process of redox process in electrochemical cell. So what happens? Anode dissolves, oxidation takes place near anode, and it dissolves, and the metal ions that is formed during this dissolving process from the bath gets deposited on pure metal over the cathode. Here you can see an example how a key can be electroplated using copper. So copper is taken as anode here. So we need to coat this key with the copper metal. So you can see the anode and cathode. So object to be plated acts as cathode here. So here one more diagram where it represents the clear picture about the reaction also that takes place during this electroplating process, where you can see at cathode what happens is copper gets deposited on the surface of the article. So here Me is nothing but the material or the substrate. Here you can take the example of key itself. So what you can see, the orange line deposited on the material or the article or the substrate. So here at anode what happens, copper gets decomposed to Cu2 plus ions, metal to metal ions, then it gets deposited as metal on the surface of the article, where Cu2 plus gets deposited in the form of Cu. And how the reaction can be represented. So you can see here at anode what happens, the metal releases the electron, and at cathode the common reaction that we are all aware about. So next one we will be discussing about the electroplating of chromium. So how this electroplating of chromium is carried out, what are the condition that we need to maintain, and what are the main composition of the plating bath, mainly the current density. So these various factors has to be clear before we start with the electroplating of chromium, as well as about the metal ion concentration or the cathode or the anode part, which acts as cathode and which acts as anode, and pH of the electrolyte solution, as well as temperature of the bath. So all these matters here. So here chromium electroplating, we have decorative chromium and hard chromium coating. So what are the conditions that has to be maintained for decorative chromium is mentioned here. So where you can see anode, usually the insoluble anodes are used, and cathode is nothing but the object to be plated. So object to be plated, or it is pre-treated usually. And what is the bath composition here? Electrolyte bath. So acidic solution is used here, as you can see the chromic acid and sulfuric acid mixture in 100:1 proportion is used as electrolyte bath. So maintaining the pH is also important, that is why the exact proportion has to be maintained, and the operating temperature for this is around 45 to 55 degrees Celsius has to be maintained, along with the suitable current density. And here mainly the application of this decorative chromium we can observe mainly for providing decorative purpose or corrosion resistant finish to any automobile part, as well as in case of surgical instrument also we will go for this decorative chromium electro deposition or plating. So this is about decorative chromium electroplating. What about hard chromium electroplating? What condition is maintained? So there is usually the change in bath with respect to temperature we can observe. So we need to maintain slightly higher temperature compared to your decorative chromium, as well as there is variation in the current density also, and it is used in industrial and engineering application. In case of your hydraulic cylinders, diesel engine cylinder, cutting tools and metal forming tools, etc. So you can see the condition of electrolytic bath also here, where electrolyte used is a mixture of, again the same composition is used, chromic acid and sulfuric acid. So here mainly it is water resistant deposit. That is one of the limitation of hard chromium electrodeposition or electroplating. So this is about electroplating of chromium, what are the conditions has to be maintained and how it is carried out, and what is the reaction that takes place during the electrodeposition process. Because here mainly we know that plating bath contains this chromic acid, nothing but the chromium trioxide, CrO3. You can see the electrolyte bath composition also here clearly, CrO3 and H2SO4. So this plating bath which contains trioxide, so in which chromium is present in, if you calculate the oxidation state, what is the oxidation state here? So oxidation state of chromium, if you calculate CrO3, it is plus 6. So during the electroplating of chromium, what happens is Cr6, the oxidation state is reduced to Cr3. So plus 6 is reduced to plus 3 state. So there is reduction process, we can clearly make out, decrease in the oxidation state. So in the presence of this sulfate catalyst, from where we get this sulfate catalyst? Here we are using sulfuric acid also as an electrolyte bath. We have seen it is nothing but the mixture of chromic acid or chromium trioxide and sulfuric acid. So this sulfuric acid will generate this sulfate catalyst. So this will assist in the reduction of chromium 6 to chromium 3 state. As you can see from the equation also, chromium 6 chromate ion. So how in the presence of water, how chromic acid is converted into H2CrO4 and how this is reduced to its Cr3 plus form. So Cr2O7 chromate ion. So that chromate ion is reduced to Cr3 plus 6 to 3 state. And finally chromium 3 is reduced to chromium 0, that is plus 3 state to 0 oxidation state, and at this stage it gets deposited on the article. So you can see the change in oxidation state, plus 6 to plus 3 followed by plus 3 to 0 state, which gets deposited on the article surface. So this is about the condition for decorative chromium electroplating and hard chromium electroplating, as well as about the reaction. What is the reaction that takes place during the electrodeposition process, where how the sulfate acts as a catalyst in assisting the reduction of Cr6 state to Cr3 state. So next is about electroless plating. So we have discussed about electroplating. Now about electroless plating. So what is this electroless plating? So it is nothing but, it is also the deposition of the metal or film of metal from its salt solution onto catalytically active surface. So nothing but coating the article itself, but here we use suitable reducing agent without using electrical energy. That is the difference here. So that is the main difference between electroplating and electroless plating. So how you can define electroless plating? It is a controlled deposition of film of metal on the metal surface or the article surface without using electrical energy. So we are not using electrical energy, whereas supply of electrical energy is required in case of electroplating. So what you can see here, during the electroless plating process, metal ion in the presence of reducing agent is converted into the metal and gets coated on the surface. So metal ion from the salt solution gets coated on the article or the substrate body. So what are the main advantages of this electroless metal plating? As the definition itself indicates here, use of electrical power or electrical contacts are eliminated. Mainly use of electrical power is eliminated, and semiconductors and insulators are also can be plated using this method. whereas in case of your electroplating, where we are using the electric energy, we cannot plate or we cannot electroplate the insulators, but using this method easily we can electroplate the semiconductor as well as insulators also. So if you compare the throwing power, always electroless plating bars have better throwing power, so that the surface is uniformly coated. In case of if the article is having irregular shape or tubes, etc., and here the harder electroless plating are harder than that produced by conventional electroplating. So nature of coating is also better compared to your electroplating. So here no levelers are required also, as well as these resulting deposits have unique chemical, mechanical and magnetic property. So this is about the advantage of electroplating. Now we will be discussing about electroless plating of nickel and copper. Two examples we are going to discuss, and about its application also. So mainly this nickel, how this nickel coating is done using electroless plating method. So mainly this nickel electroless plating is used in your automotive industry, and also it is used for bright work on bicycles, and also it is used for in electronics connectors, as a connectors for electronics, which is for that common application we can observe at homes, automobiles and mobile phones also. So how this nickel electroless plating is carried out? So first thing, before we go for the electroless plating, always the object has to be pre-treated. So surface of the substrate or the article has to be pre-treated. So how this pre-treatment is carried out? So in case of electroless plating, pre-treatment has to be carried out to the substrate. Here what has to be done? First, the article to be plated, it has to be degreased and cleaned completely. It has to be degreased and etched by the treatment with some organic solvents and acid. So degreasing and cleaning process has to be done. And this in case of iron, aluminium and brass, electroless plating of nickel is deposited directly on these such metals like iron, aluminium and brass without any treatment in the presence of reducing agent. So directly you can take the reducing agent and the bath condition you need to maintain. Then directly you can deposit this nickel by using this electroless technique. That is possible only in case of iron, aluminium and brass. So in such cases pre-treatment is not required, direct deposition is possible. But in case of non-metallic materials like plastics, glass, insulators kind materials, if you are using like plastics, glass, then the catalytically the surface has to be activated. So how we can activate the surface? So the surface can be activated by dipping in stannous chloride containing hydrochloric acid at 25 degrees Celsius, followed by treating with palladium chloride. So here first thing, always the article has to be, the surface of the article which we want to go for the coating has to be cleaned. It has to be degreased and etched by using some acid or organic solvent. Next, in case of if you are going for the coating of iron, aluminium or brass, then directly this nickel can be deposited by using this electroless plating method without any further treatment. But if you are using any insulators or non-metallic materials or semiconductors, maybe like plastics or glass, then the surface has to be activated. How this surface can be activated? As I mentioned, by dipping the article in stannous chloride containing hydrochloric acid and followed by treating with palladium chloride. So here you can see in the slide where you can see clearly the conditions that we apply in case of electroless plating of nickel. What are the plating bath solution requirements? So you can see the metal ion solution is usually nickel chloride, and the concentration is also given, usually 20 gram per liter has to be taken. And what is the reducing agent? So in case of electroless plating, as I have explained the reaction also, use of reducing agent is important. So you need to mention the reducing agent. So here sodium hypophospite is used as reducing agent. And to avoid the change in pH, we need to use sodium acetate buffer, and the complexing agent used is sodium succinate, and temperature of the bath solution has to be maintained around 93 degrees Celsius, maintaining the pH level at 4.5. So these are the bath requirement or the plating bath solution condition that has to be maintained during this electroless plating of nickel. So already we have discussed or mentioned about the application part also. So first step is always the pre-treatment in case of electroless plating, where first thing is degreasing, removing any oil or dirt impurity from the surface of the article or substrate. Next one, depending on the nature of the metal which we want to, which the article is made up of. If it is of iron, aluminium, directly we can go for the bath solution deposition, whereas if it is in case of insulators and semiconducting materials or glass, plastics, etc., we need to treat the article with stannous chloride containing hydrochloric acid, and also followed by treating with palladium chloride PdCl2. So this is about electroless plating of nickel. Next is about electroless plating of copper. We are going to discuss about the electroless plating of copper and also about its main application. So next is about electroless plating of copper. So how this electroless plating of copper is carried out. So the first step always involves the pre-treatment as well as the activation of the surface. So how this is done? By degreasing the surface by etching in acid, and activated by dipping first in stannous chloride containing HCl and then in palladium chloride. And you can see the composition of the plating bath solution, where the electrolyte used is copper sulfate, and the reducing agent is formaldehyde, and EDTA is used as the complexing agent here. And you can see the reaction that takes place at anode and cathode, reduction and oxidation process, where you can see the reaction arrow mark is missing. We Cu2 plus 2 electron giving rise to copper, and formaldehyde with hydroxyl ion, where it gives the formate ion HCOO minus. And also you can see the overall reaction here. So what are the applications of this electroless plating of copper? So here mainly it is used in printed circuit board electronic applications for producing through hole connections. Mainly you can see this application in case of you are designing the PCBs or printed circuit board. And for plating of non-conductors, that is also one of the application as a base for subsequent conventional electroplating. And also this method, electroless plating of copper, is applied on waveguides and decorative plating on copper. So now we will be highlighting about one of its most common application, that is nothing but designing the printed circuit board, double-sided circuit PCBs. How this can be done using electroless plating of copper, that we are going to discuss now. So let us discuss the application of electroless plating of copper in designing PCBs. So for printed circuit boards with double-sided circuits, through hole connections are required, and it is made by electroless plating of copper. So how this electroless plating of copper is done here? Here the process involves initially the plastic board or the base material has to be degreased and etched in acid. So then it is activated using stannous chloride solution containing acid, and followed by treatment with palladium chloride. Then the surface has to be dried to get the layer of palladium catalyst. So this activated board or the base material is then immersed in a plating bath solution for electroplating of copper. So here the plating is carried out till the required thickness is obtained. Next, the selected areas where we want to design the circuit, we need to plan the circuit design, and the selected areas are protected, and rest of the copper is removed by etching process with suitable etchant. So, produce the circuit pattern. So, connections between the side of the track, that both the side of the track is made by drilling a hole followed by plating through the hole by electroless plating process. So, here the contact between the two sides, it is made by drilling holes at required points, as you can see in the diagram. Then finally the holes are plated by electroless plating of copper. So, you can see the diagram also clearly, where the plastic base material, that can be glass also or the polymeric material also. So, this base material has to be degreased. After that, it has to coated with copper by electroplating of copper process. Next, the circuit pattern, copper is selected areas are protected, and copper is etched by the etching process. Then the connection between both the sides, it is done by drilling holes. So, through holes are produced by drilling process. Next to that, we need to activate the holes by electroless plating through the hole. So, this is what the application of electroless plating of copper in designing PCBs, as you can see the diagram. So, with this we have discussed about various examples of electroplating and electroless plating, and it is its importance also. So, thank you.